solutions architect here with the Global Financial Services Group within AWS. We help FinServ firms get to the cloud, adopt the cloud, understand the cloud. So my role is, technology advisor, helping understand the platform, how to migrate, how to govern what you build in AWS. So my talk today is a collection of emerging patterns and practices that are helping our FinServ customers with building infrastructure in AWS with better auditability in mind. So the first part of this talk is just a quick review of how to approach compliance in AWS and what you build in AWS. And the second part of the talk is a quick tour of a variety of governance patterns, particularly around user access control, which is a big topic in IT governance compliance. So compliance means many things in financial services. It could mean Dodd-Frank stress testing. It could mean anti-money laundering and banking. It could mean, if you're lending, making sure your loan portfolio or making sure your loans are fair. And we certainly have financial services customers who build those types of systems in AWS, and we have partners who specialize in that side of compliance and regulation. This talk is more focused on the IT governance piece and how can you build systems that have auditability in mind for better IT governance compliance. So a quick review of compliance in AWS. We have, of course, a website where you can download and look at the variety of compliance programs around IT governance that our platform is aligned to. So we provide documentation on how we aligned our security practices and our internal governance to these frameworks. We also have an internal website that you can reach from inside your AWS account to download our detailed audit reports from our third-party auditors. So that's helpful for understanding our controls and how we align our practices to these and many other frameworks. There's also a documentation on how to think about the responsibilities between AWS and yourselves if you need to put a workload in AWS that's, say, for example, PCI compliant. So as part of the artifact download for PCI package, there's an Excel sheet that shows you for all the PCI controls. Here's the controls that AWS can attest to, and here's the controls that you ought to think about. So that gets into our shared responsibility model that applies to security and compliance. So again, suppose your objectives are to prove SOC compliance, ISO, PCI, HIPAA, etc. How you do that in AWS is your auditors in total want to see if all your controls meet these standards. For the things you don't have direct control over, like the physical infrastructure, the facilities, the lower level layers of the cloud, you refer to AWS attestation of those controls. For the things you do control in the cloud, your configurations, your security groups, your firewall rules, etc., all the configurations that you control in AWS, you also prove to your auditor that you have those up to the appropriate standards. So it's the sum of those things that proves compliance with these frameworks. So we have many customers in AWS who are PCI compliant, for example. And this is how they do it. So that's what we refer to as the shared security model. So, or a shared responsibility model, rather. So customers often ask us, well, where do I start? And where do I even begin to put this kind of program together? So with any compliance program, it often comes down to a spreadsheet of the controls. We've talked to many customers and asked, what are you using for your GRC software, your governance risk mappings? What are you using? Most often the answer we hear is Excel. There's other software out there, but often it comes down to a grid of what's the risk, what are the requirements, and who owns that system. Because this is the map that helps you get through the audit. The auditor's going to ask, what are you doing to control access to customer data? So you fill this sheet in a way that helps you quickly map to who to talk to around that set of controls. So for example, just filling this in, the risk is unauthorized access. The particular requirement is disable inactive employee logins. And then you have your control references of which control frameworks actually require that and what is the requirement. So the top 3 rows would speak to what are you doing on-prem? What are you doing in your own corporate systems on-prem? How do you do this in AWS? Well, it's basically the same thing. You can add more rows for, and how do we do it in AWS? What are the technical controls there? Which team do you talk to? Or which team do you refer your auditor to go find out more and how that's being controlled and where the evidence is. So typically these spreadsheets are much bigger, much longer, but this is just a small scale example. So that's just a quick review of what the compliance journey typically looks like in AWS. But design for compliance is more about how do you proactively design systems and architect things to help your IT governance audits go a little smoother. So in particular, I'm going to look at access control. It's a big topic within IT governance. It's often hard to solve at a big scale. So I want to show you some design for compliance patterns like immutable production, zero trust architecture, role-based access for systems, change management, etc. I'm going to talk about some of the AWS services that help you address these things in a way that helps you produce evidence for your auditors pretty quickly and explain to your auditors how that's being controlled. I'm going to do it by way of example of a few example audit findings. These are just examples of, if you move some workloads into the cloud, you start moving in at scale. If you move things in a way that's not designed for compliance, you're just moving quickly, and then you have a third-party auditor come in, or your internal auditor comes in, takes a look at what you did. They might produce some audit findings, such as you don't understand your permissions landscape. You have so many things going on, or you put too many things in the same environment that your permissions are confusing. It's confusing to the auditor. It might even be confusing to some of the systems owners. So how can you avoid that? Secondly, developers have privileged access to production. We sometimes hear this with customers who are trying to adopt DevOps. And so DevOps, it's often assumed that the developers control operations, which is a good practice. But how do you do it in a way that your auditor is going to be okay with and prove to your auditor that it's under control? And third, internal systems lacking user authentication. We sometimes see this where you have internal APIs on-prem that implicitly trust anything that's on the internal network without any user authentication. So when you bring that kind of workload in AWS, we have services that can help you quickly turn that into more of a authorization, authentication, rather than just network controls. So I'll talk a little about that. Okay, so taking the first example, permissions management. Entitlement owners have insufficient understanding of permissions, resulting in inappropriate access, incomplete access reviews. In other words, your auditor's opinion is that you don't understand your permissions landscape. Maybe it got too complicated. We see a few different causes of this. One cause is a proof of concept environment became production. In other words, a development team built out a new capability pretty quickly, launched it, and made it go live in the same environment, which became production. And I'll talk a little bit about the complexities there and how to avoid it. Another cause, dev, staging, and prod are in the same environment, so you don't have a clean separation between your dev permissions and customer data. It's kind of all in the same environment. How can you avoid that? And overcrowded AWS environments, putting too many things in the same AWS account, and I'll talk a little more about that as well. So taking the first situation, example cause dev became production. So in this situation, we sometimes see it where, again, a POC was built out in an environment, and then live customers were added, and then, the POC environment became production. So what happened here was the development environment permissions, which were kind of liberal, kind of open to let the developers kind of experiment, add live traffic, and it became production. There was no rebasing of the permissions. There were persistent permissions, etc. So how can you avoid this? Well, in AWS, we have a service called CloudFormation, infrastructure as code. So what we advocate here is, go ahead and build out your MVP prototype, build it out in a production environment, very liberal permissions. There's no customer data there. And then when the MVP gets to a mature stage of this is working and this is the design we want, you then build a template of that environment. So in AWS, we call this CloudFormation, infrastructure as code, where basically you can express that whole architecture as code and bring that template over to a completely different environment, a different AWS account, and launch it from scratch. That'll effectively rebase the permissions and build a clean room version of that architecture again with just the least privileged permissions. So just doing that alone will avoid the situation of carrying over development environment permissions into another account. This also gets into kind of having a multi-account strategy, and I'll talk a little bit more about that. So getting to the point of overcrowding AWS accounts. So in AWS, an account is not a single user login. It's not one person. When we say AWS account, we're talking about a whole container of cloud infrastructure. Now, early in the cloud journey, some security and governance teams might assume that it's easier to have one AWS account and treat it like one data center, and then have a lot of teams work in that one AWS account. That can often get really complicated, as you can see illustrated here, because you start to have a bunch of random folks, random roles, random projects all in the same environment. And it becomes really hard to discern whose permissions are who belongs to what, who belongs to which project, how do you divide up the costs. When it comes time to audit something like this, that's where the auditor is going to raise the finding of you don't understand your permissions landscape, because nobody understands this. It's a big shared environment. So what we suggest to enterprises, and certainly FinServs, is have a multi-account strategy. So at least have different AWS accounts for different departments and different teams. Often the account structure in AWS will kind of resemble your org structure. That's what typically makes the most sense. You also have another dimension of dev versus staging versus prod. So that's another very typical separation. And that way you cleanly have customer data in its own AWS account governed by a team that understands that architecture. So you can sort of think of it as single family homes, where the family that occupies that home understands the architecture and they understand what's going on in that account. Now, when you go down this path as an enterprise, you're typically going to end up with hundreds of AWS accounts. And sometimes central security team will get scared of that and think that's too many to manage, but it is manageable. It does end up being better for cost and security reconciliation. So we also have FinServ customers like Thomson Reuters who've spoken at reInvent about their multi-account strategy and the kind of architecture they built to help govern it. So that's a really good talk if you want to go deeper on this topic. We also have, we're working on a new service that we announced at reInvent called Control Tower. And this helps you launch multiple AWS accounts with the guardrails that are appropriate for your organization. So we know that a lot of enterprises spend a lot of energy building that account-making machine. Every time someone asks for a new account, they gotta spin up the account, put the guardrails in, enroll it in support, link up the billing, so on and so on. So Control Tower is a new service we're building that helps you do all that. So that's really great for governance too, and it helps you manage a multi-account strategy. Another common feature of an enterprise build out in AWS is having federated access into AWS, so access that ties back to your corporate identities. That's really important. All the staff, all the associates that are accessing AWS, it should be tied to their corporate identity, getting back to the requirement of when somebody leaves the company, their permissions have to be cut off everywhere. So this is how you accomplish that. You either federate with your Active Directory into AWS, or you leverage the AWS SSO service. Makes it real easy for you to set up centralized federated access into AWS. So that's for human access to AWS. We have another kind of role-based access I'll talk about called service roles. And another service of AWS that helps you centrally manage permissions and guardrails is AWS Organizations. So if you haven't used it yet, this is a really powerful way to centrally manage permissions and set guardrails. This example on the board demonstrates if you have an admin role in every AWS account in order to allow your security team to centrally manage everything. And you don't want to allow people to delete that role, for example. Organizations is the kind of service you would use to set those kind of guardrails. Last week, we announced some new features in Organizations. For those of you who've looked at it before and compared it to IAM, our IAM service, Identity and Access Management, is where you manage very granular access policies in AWS, but it's per AWS account. Organizations will span your whole fleet of AWS accounts. So it gives you one central place to set guardrails. We recently announced these new actions at the bottom here that mimic what you can do with IAM policies. So organizations policies are now more granular. So it gives you even more ability to essentially manage your permissions. Okay, so that was, addressing the first finding of insufficient understanding of permissions. I'll go back and summarize those later, like what kinds of services will help you, but I'll move on to the second finding. Developers have access to production. So let's say the auditor writes it like this. Developers have been granted access that allows migrating changes to production. So the real concern here is not that DevOps goes against any regulatory requirement. It doesn't. You can still be DevOps. But how do you do DevOps in a way that speaks to nobody is self-permissioned to make changes to production? So some underlying causes, humans are deploying changes to production. What that speaks to is a lack of automation. Wherever you have lack of automation, you can lose auditability, and you basically have privileged individuals who can make changes to production without approval. So you want to use automation and kind of get rid of that situation. Change approvals are not correlated to change deployments. In other words, a lack of a change management system or a lack of documentation as to why production was changed. It's one thing to have logs that tell you that something changed, but if you can't correlate it to why and who approved it, then your auditor is not going to be happy. So how do you avoid that? And lastly, developers demanded production access for fire call escalations. In other words, break glass. Again, going back to DevOps. if you make developers more responsible for operations, implicitly they need some sort of break glass procedure to deal with production situations, to go in and fix things that are broken live. So how can you facilitate that without, drawing the ire of your auditors? So getting back to deploying changes and automation, lack of automation, the posture we recommend is immutable production. The idea of immutable production is basically the posture of no humans allowed in production. It's easier said than done, but there are ways to accomplish this. But once you can tell your auditor, we don't allow humans in production, and you can prove it, it makes your auditing, IT governance auditing, a whole lot easier. So I'll talk about how you actually do this. First of all, it's obviously in your CI/CD tooling. You have to have a lot of automation to develop in one environment. In other words, one AWS account, you do your development. Then you have a staging environment, which is a copy of production. And then you have automation that delivers the code into production, and you do a lot of automated monitoring. And it's typical in financial services that you want to pull production data back into staging to run your tests against a copy of production, but you have to mask it. So it's typical of our FinServ customers to use tools like Delphix to mask production data and bring it back into lower environments to make sure staging is a high fidelity copy of production. But the whole point of this is if you stick to the rule of no humans in production and only tools can change production, then it just becomes a challenge of controlling access to the tools. Who can push the button to deploy? But once you got that button that can deploy and no humans involved, your auditability is vastly improved. So the second piece of this is the change management and the auditability of changes and who approved it. That's really what separation of duties is all about. It doesn't mean that you can only deploy in production if your job title doesn't have the word developer in it. That's not what it means. What it means is separation of duties. Nobody's self-permissioned to change production. So in a DevOps way, something as simple as a code review that can justify the production change to prove to your auditor that, yes, production was changed, and here's the actual reason it was changed, and here's who approved it. Once you have that audit trail of tying every change back to an approval and back to who approved it, now you can prove separation of duties. And of course, your tool should also produce logs of test results, deployment logs, etc., that you can then tie back to the actual change approval. So now you close the loop on who changed it, why it changed, and who approved it. And it was done in a way that no single human in your organization could do that without other people approving and noticing. So, these slides are doing something weird on this display, but okay. The other thing I mentioned was in a DevOps posture, you might end up with developers have persistent access to production. Your auditor's not going to like that. How do you address that? That has to do with just-in-time access. And again, using access approval, so you have an approval flow even for break glass access. So how can you do that in AWS? Suppose there is a problem in production and an engineer who understands that problem needs to get into production and look around and diagnose. How do you approve it? Typically, you can have like an internal access control portal or some sort of ticketing system where that person goes in and asks for temporary production access. Another human has to review that ticket and approve it. Again, nobody's self-permissioned to do anything. You got to have at least 2 people to approve this. Once that's been approved, in AWS, you have an IAM action called, assume role, basically role-based access into the production environment. Now what's cool, because AWS is all API driven, is you can create that role on the fly, and you can name the role role according to the access ticket. And the reason for that is to close the loop on auditability. So the engineer goes in, they diagnose, they look around. That role, they assume, can also have read-only access. So you can prove that they couldn't actually change anything. They could only look, and the only way to remediate was to perhaps push another change to production. Depends on what posture you want to take, but you could go to that, you could do that as well. And then finally, in AWS, we have what's called the CloudTrail log, which lets you tie everything that particular IAM identity did in that environment goes back to a log. So again, if you created the role according to the name of the ticket, what's going to end up showing up in the log can easily be tied back to that access ticket. So you can prove to your auditor that the access was temporary, it was read-only, and everything they did is tied back to the log. So that's an example of design for compliance, kind of. It's one thing to just build systems where you allow people to have access, but it's another thing to build it out in such a way that you have auditability in mind. Another thing when it comes to giving engineers and developers access, or even operators access to production, is the standard pattern in our industry is jump boxes and SSH bastions and so on. This has been standard practice for a long time. In terms of auditability, it's kind of tricky. First of all, because it's persistent permissions. Often it's SSH keys, which can linger there for a long time. Secondly, you can lose trackability of what that person did after they left the jump box. They jumped into something else, and you kind of lose their audit trail. There's ways to fix that, but it does require some engineering to kind of close that loop. On our platform, we have a service called Systems Manager, which is an agent-based service, which you can run on virtual machines, either in AWS or on-prem. You choose where to put this agent. What's really cool is it has a feature called Sessions Manager, which basically gives you SSH-like access, but it's tied back to roles. It's based on ephemeral credentials, essentially, and it's auditable. Everything that person did, all their commands and all their output, is saved to an indelible log. So you can prove to your auditor that, yes, they got in, they were granted temporary access, and here's everything they did. And what's nice about the setup is you don't have to worry about allowing SSH ports, you don't have to worry about distributing SSH keys, et cetera, et cetera. It's all tied back to IAM roles. So that's a really cool feature for managing access to systems. At AWS and Amazon in general, we're obsessed with weekly metrics. That's kind of how we drive internal programs and initiatives, is we basically come up with an owner for that initiative, and that owner collects metrics and tries to drive those metrics down to an acceptable SLA. So keeping that in mind, you may, if you want to push for immutable production, you could treat anytime someone logs into a production system as kind of an undesirable situation that you want to drive down to a low acceptable level. So through Systems Manager and CloudTrail logs, et cetera, you can, and our CloudWatch service, you can start to gather metrics on how often people are getting into production. And then you can chase down those teams and ask them why, and why are you going into production so often, and help those teams kind of adopt patterns like immutable production to help drive these metrics down. So our platform makes it easy to kind of pull together these metrics and report on that and help you, drive the right practice. Also, when it comes to just-in-time access and privileged access management, we have partners in this space. So CyberArk, Okta, Centrify, Beyond Trust, and many others, they specialized in privileged access management, granting just-in-time access management, having access audits, et cetera. So if you need more help in that space, we have some partners who specialize in that. So third example of an audit finding, internal systems lacking user authentication. So let's look at the actual language. It says internal systems lacking access restrictions based on user identity and job role. So underlying causes, most commonly it's just relying too heavily on network access controls, firewall rules, etc., to establish trust. Another example is just considering anything in your private network to be trusted without any user authentication or authorization. Which is the second point, lack of user authentication authorization on internal services. We often see this with homegrown APIs where it was easier to stand up that API in a trusted internal environment, and implementing user access and authentication is a lot of engineering work, so it often ends up on the backlog. And again, overcrowded environments, just putting, again, too much stuff into the same environment, too many different teams, could also cause this situation of things not separated cleanly by user and job role. So looking at an example architecture that could, cause this kind of finding, again, user access based just on firewall rules. Here you see that address range, the 6423 address range is pretty wide. So that's just trusting any IP in that range. You could have an external partner that matches part of it, but it's just too wide. And there's nothing in the firewall rule set explaining why that was left open. And when it comes to zero trust, at the RSA security conference about a month ago, the buzzword of the conference was zero trust, and it had to do with limiting lateral movement within your network. So once they're in your internal network, you want to limit their opportunities to move east and west to make lateral movements to other parts of your internal network. So the zero trust idea is you basically implement authorization, authentication, just about everywhere you can. So in AWS, kind of reconsidering that sort of architecture, how can you do more of a zero trust kind of posture in AWS? Taking the same architecture, you start with your typical DMZ where the external traffic comes in, and you can use our services like CloudFront, WAF, AWS Shield to kind of insulate you from the hostilities of the external internet. So whether it's DDoS attacks or just injection attacks, etc. That's kind of your typical. We also have a lot of partners in that space as well, but those services typically help you, insulate you from some of the attacks coming off the internet. And then when it comes to authorization, we have a service called API Gateway, which gives you like a front end to your REST API, but makes it really easy to add authentication to your REST API. So you can pretty much, take similar code that you wrote on-prem for your internal APIs and bring it to AWS. And method by method, you can add role-based authentication to your API. So, an external user request comes in, it goes through, the edge services first, and then reaches API Gateway. API Gateway's got its own load balancing and routing built into it. And then from there, it goes to your internal backend services. You could have made them serverless with Lambda functions, or you could have used EC2 instances. And then what gets really interesting when it comes to zero trust and role-based authentication is even internal servers and functions in AWS can have a role. So you can have role-based access, the RBAC, role-based access control, for systems in AWS. So you can permission a virtual machine to talk to a database without using static credentials. And I'll talk a little more about that. Same thing with your serverless functions. You can permission serverless functions to take on a role to talk to certain APIs using, not using static credentials, but using role-based access. So a little further into that, avoiding static credentials. The classic way to permission things in AWS or databases was to use, secret key and access keys. increasingly we release capabilities to move away from that and stop using static credentials and persistent credentials. You want to use system-based roles for your systems, for your Lambda functions, etc., to permission the role to use the resource rather than using static credentials. For those things that still require static credentials like databases, we released Secrets Manager, and we also have a lot of FinServ customers who use HashiCorp Vault. So those kinds of solutions help you do basically, getting secrets on demand to log into something, but the access to the secret is controlled by roles. So static credentials can still exist in your AWS environment, but you want to stay on top of it. So especially for auditing activity, in our IAM console, Access and Identity Management, you can download a credential report, which is a spreadsheet that will tell you a number of useful things. It will tell you how many static credentials you have, when's the last time they were rotated. This works for both AWS console access as well as access keys. So that's a very important report to stay on top of. Helps you identify quickly if you have any persistent logins that require rotation. Also, AWS gives you the ability to kind of force rotation of passwords, etc. So a lot of these options are turned off by default. You go in and turn them on to whatever your rotation policy dictates. Okay, so a summary of some of the audit findings I mentioned and what helps you address those. Insufficient understanding of permissions. In AWS, we advocate a multi-account strategy for large organizations and FinServ, so you have different accounts for departments and for dev staging and prod. To help you manage your multi-account strategy, you want to centralize your permissions, so you can use AWS SSO. You can use AWS Organizations for kind of umbrella policies that span your whole fleet. And Control Tower will help you create AWS accounts with all the standard controls already built in. For privileged access to production, whether it's developers or operators, any human whatsoever, try to design things proactively with immutable production in mind, so only tools change production and not people is kind of the posture to take there. Try to integrate your change approval tickets with your CI/CD to tie them back. So any change that goes to production can be tied back to an approved ticket. And look for just-in-time access solutions like our partners that specialize in PAM solutions, or not too hard to build your own, but basically have a solution for break glass access. You are going to need break glass access, but it's all in proving that it was approved and it was temporary. And as far as internal systems lacking user authentication, that goes back to like zero trust architecture, just making sure that you have authentication, authorization, and as many layers as possible. Try to avoid persistent credentials. Our API Gateway service, if you're building REST APIs internally, API Gateway makes it really easy to build those out with authentication. Our RDS database service also has role-based access to systems with IAM authorization. We have AWS Secrets Manager for managing role-based access to credentials. There's third-party tools like HashiCorp Vault. And the credential auditing report is really important for just checking all your AWS accounts to see if there's any persistent credentials that need to be rotated. And that's it. Simple as that.